black hole can pack more mass than our sun into a region only a few miles wide, while the biggest known ones outweigh billions of suns and shape entire galaxies. Some may have formed from dying stars, some from the early universe, and some might still be only ideas waiting for proof. In this video we cover stellar mass black holes, intermediate mass black holes, supermassive black holes, primordial black holes, and micro black holes. If you want every major type broken down in one place, subscribe. We do this for everything. These are the black holes we know best, formed when a very massive star runs out of fuel and its core collapses under its own gravity. If enough mass remains after the star explodes, the core becomes so compact that not even light can escape. Most are a few to a few dozen times the sun's mass, and many are found by watching hot gas glow as it falls in from a nearby companion star. The first black holes detected through gravitational waves were stellar mass pairs crashing together, turning a tiny bit of mass into a huge burst of energy. From these common cosmic leftovers, the story grows bigger with intermediate mass black holes. Intermediate mass black holes sit between the small ones made by stars and the giant ones in galactic centers, usually ranging from hundreds to hundreds of thousands of solar masses. They may form when many stars and smaller black holes merge inside crowded star clusters, or when unusually massive early stars collapse. They are hard to find because they are not as active or obvious as larger black holes, so astronomers look for stars whipping around an unseen object, or for ripples in space from mergers. Strong evidence has finally appeared in recent years, including objects around 50,000 solar masses. These rare middleweights may help explain how the universe built the truly enormous black holes next. Supermassive black holes are the giants that live in the centers of most large galaxies, with masses from millions to billions of suns. They grow by pulling in gas, swallowing stars, and merging with other black holes over cosmic time. When matter spirals in, it heats up and can outshine the whole galaxy, creating a quasar or other bright active core. Our own Milky Way has one called Sagittarius A*, and the Event Horizon Telescope captured images of supermassive black holes by tracing glowing gas around their edges. These monsters can regulate star formation across entire galaxies, but some scientists think an even older kind may have helped seed them in the first place. Primordial black holes are still hypothetical, but they are a serious idea in modern cosmology. Instead of forming from stars, they would have formed in the first moments after the Big Bang, when tiny regions of the young universe may have been dense enough to collapse directly into black holes. Depending on the conditions, they could span a huge range of sizes, from very small to quite massive. Scientists search for them through their gravity, possible lensing effects, and clues in cosmic radiation. They matter because if they exist in large numbers, they could explain part of dark matter and even help account for some black hole mergers. At the smallest end of the scale, that leads to micro black holes. Micro black holes are the tiniest proposed black holes, far smaller than any formed by collapsing stars. In standard physics, they might have been created only in the extremely hot early universe, and they would likely lose energy through Hawking radiation and vanish quickly. Some theories also suggest they could briefly appear in high-energy particle collisions if space has extra hidden dimensions, though none have ever been detected. If one were made in a lab, it would not swallow Earth. It would decay almost instantly. These objects remain speculative, but they give physicists a way to test ideas about gravity, quantum physics, and the birth of the universe, bringing our tour of black hole types full circle.